Hello, welcome to part 2 of lesson number 4 in our Unit 5 Solving Quadratic Equations in our grade 10 academic math class. So in this lesson so far we've talked about what the discriminant is. It's a predictive tool to help us figure out how many solutions there are going to be for quadratic equations. The thing we were just starting to talk about is a second thing that you can use the discriminant for is determining what the best method for solving a quadratic equation is. And I started by saying that if the discriminant is a perfect square, the proper or the best way to go about solving is factoring. So let's just take a moment here to talk about what a perfect square is. So a perfect square is a number that has two identical factors. So some of the common perfect squares would be like 1 or 4 or 9, 16, 25, 36, etc. So that's just going to go on down the line. So those are perfect squares. So if you end up with values for the discriminant that are perfect squares, it means that your quadratic equation is going to be factorable, and that is something that you would choose for solving the quadratic equation. If our discriminant's value is not a perfect square, so basically anything that's not 1, 4, 9, 16, 25, 36, etc., then you should try using the quadratic formula, in that the quadratic equation will not be factorable. So let's have a look at these last two examples. It says use the discriminant to determine the best method for solving, then use that method to solve the equation and round to 2 decimal places if required. So we're going to use the discriminant, pick the best method, and then we're going to go ahead and solve. So let's start with our first example here. Example A, 2x squared plus 3x minus 20 equals 0. We have a, b, and c values of 2, 3, and negative 20 respectively. There's our discriminant. Let's do a substitution here and see if we can and get a value for our discriminant and then make our decision. So I'm going to sub in here. The discriminant then will be equal to 3 squared minus 4 times 2 times negative, times 2 times, yikes, get out of there, times negative 20. And let's put that into our calculator and see what we get. So we get 3 squared minus 4 times 2 times negative 20, and that's going to give us 169. So what does this discriminant tell us? Well, if you're not sure if this is a perfect square, you can try square rooting it. And 169 is a perfect square. Its square root is 13. So we'd want to say something like here, since the discriminant is a perfect square, that's Mr. Smith being lazy, therefore solve by factoring. Okay, so let's try to factor this thing. So we have 2x squared plus 3x minus 20. No common factor, so this is going to be a tricky trinomial. So we are looking for things that multiply. Let me just do a rewrite down here. 2x squared plus 3x minus 20 equals 0. We're looking for things that are going to multiply to negative 40 and that add, that looks like 46. Negative 40, and that add to plus 3. So factors of negative 40, that looks like positive 8 and negative 5 will be the two that fulfill that for us. So let's decompose our middle term. So we've got 2x squared, we'll do plus 8x minus 5x minus 20 equals 0. Now we go on to factor by grouping. So the greatest common factor in our first two terms is 2x, leaving us with x plus 4. And we have a negative leading value here in the second half, so we're going to common factor out minus 5, leaving us with x plus 4 equals 0. One more round of common factoring here. X plus 4 is common to both terms, leaving us with 2x minus 5 in our second binomial. So this is factored. Now we need to go ahead and solve. So we're going to set each of our brackets equal to 0, and we are going to isolate the variable x. So over here we're going to transpose 4 to the other side, so that will be x equals negative 4. And our second scenario here, we're going to transpose -5 to the other side by adding 5 to both sides, and then dividing by 2 will give us 5/2. So our two solutions here, -4 and 5/2, by arriving at a discriminant that was a perfect square, we were able to solve by factoring. That was the most efficient way to do it. Okay, let's try the second example. Second example, okay, so the second example needs a bit of massaging, because here we have a 3 on the other side. We need to get the 3 over to join the other two terms. So that's actually going to be -2x squared plus 8x minus 3 equals 0. So we have our a value equal to -2, our b value equal to 8, and our c value equal to -3. And now we're going to substitute into our discriminant and see what's going on. So d equals b squared minus 4ac. A substitution step will give us 8 squared minus 4 times -2 times -3. Let's punch that into the calculator and see what we get. So we have here 8 squared minus 4 times -2 times -3, and that's going to give us 40. Now 40 is not a perfect square, so let's do a bit of notation here. So we'll say since our discriminant is not equal to a perfect square, that's just Mr. Smith being lazy, therefore quadratic formula to solve. So we're going to use our quadratic formula to solve. Now what's nice about using the discriminant as a predictive tool for the best method for solving is that we've actually already found the discriminant value, and that one can kind of be the pain to find in all of it. So let's start by writing out our quadratic formula here. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Let's do a substitution step here. So we've got -8 plus minus the square root of 8 squared minus 4 times -2 times -3 all over 2 times -2. Now, as I said, what's neat about this is we already know the value of our discriminant. The part under the radical sign is going to be equal to 40. So there's actually just only a little bit of math here to do for us. That's going to be -8 plus minus the square root of 40 all over -4. And now we're going to work those two possible answers, where our first one is going to be x equals -8 plus root 40 all over -4. And our second example over here, our second scenario here, where you've got -8 minus root 40 all over -4. And again, I'm just going to bang this through the calculator and see what we get. Remember, you want to finish your numerator before you do the denominator. You can achieve this by putting brackets around the numerator, or you can achieve this by hitting a hard equals when you're done the numerator's calculation. Either way. So let's start with -8 plus root 40 equals, and then so that's -1.675, etc. I'm going to keep that in my calculator, and I'm going to divide by -4, and that's going to equal 0. That's still my highlighter. 0.42 approximately. I think it said 2 decimal places in the original question. And now our second, so we're going to start with -8 minus root 40 equals, and then divided by -4 equals, and that will be x equal to approximately 3.58. Let's pop in my x in there. Okay, so that is another way for us to utilize the discriminant, is to determine the best way for solving a quadratic equation. So at the bottom of the lesson there's some homework. Go through the homework. There's a review for the test down at the bottom there. You're welcome to try some of those questions as well. Again, time permitting based on your schedule. Otherwise, best of luck with the homework on this lesson. If you have any questions, email me for sure. I've been putting videos out of answers or solutions to homework questions where I talk through them if a number of students are stuck on them and answering you by email isn't really working out. So by all means, reach out. I'm happy to help. I'm here to help. And good luck with this last lesson in Unit 5, and I'll see you in Unit 6.